You are welcome to this YouTube channel. We are looking at stoichiometric calculations. Please don't forget to subscribe to this channel, share and like. Don't forget to subscribe, share and like. So we are looking at stoichiometric calculations. We shall be treating examples on stoichiometric calculations. So we are looking at the first example, and the question is, calculate the mass of sulfur 4 oxide obtained when 91.0 gram of oxygen react completely with sulfur according to this equation below. Now from this question, in stoichiometry you consider the two substances that are related together. So our concern will be based on the products sulfur 4 oxide, SO2, and sulfur. Sulfur 4 oxide is the products, while sulfur is the reactant. So we are calculating the mass of sulfur 4 oxide that 91.0 gram of oxygen will react with. Don't forget again to subscribe and like this video and share. So sulfur 4 oxide and oxygen, those are the two substances. So the mass of sulfur 4 oxide produced when 91.0 gram of oxygen react completely with sulfur according to the equation. So you concentrate on oxygen and sulfur. Now in stoichiometry we have different relationships. We have mass to mass relationship, we have mole to mole relationship, we have mass to mole relationship. But according to this question, we are using mass to mass relationship. That is, we want to calculate the mass of sulfur 4 oxide from the mass of oxygen that reacts. So let's go. So you start from the balance equation. You start from the mole to mole relationship. So we have from the equation, you start from the mole. So we have 1 mole of oxygen. 1 mole of oxygen reacts to produce 1 mole of SO2. Don't forget we are using mass to mass relationship. So we are going to convert the mole of oxygen to mass in gram. And we convert the 1 mole of SO2 also to mass. Now if you want to convert mole to mass, you will need the molar mass of the substance. So to calculate the molar mass of oxygen from the atomic mass you are given, you multiply the number of atoms by the atomic mass and you put the unit gram per mole, and that gives us 32.0 gram per mole. That's the molar mass of oxygen. The same way we calculate the molar mass of the other one, which is sulfur 4 oxide, molar mass of SO2. You add up the atomic masses of the atoms, sulfur and oxygen, so you have 1 times 32 plus 2 times 16 gram per mole, and that gives us 32 plus 32, which is 64.0 gram per mole. We need the molar masses of the two substances because we are going to convert the mole to mass in gram. We will convert the mole to mass in gram of each. So let's go back to the first statement. From the balance equation, we have 1 mole of oxygen reacting to produce 1 mole of sulfur 4 oxide. So using mass to mass relationship, using mass to mass relationship. It means 1 mole of oxygen converted to mass in gram will be the 1 mole multiplied by 1 mole multiplied by the molar mass, which is 32 gram per mole of oxygen, against 1 mole of the sulfur 4 oxide multiplied by 64 gram per mole of SO2. So you can see that the mole cancels this. Let's cancel this also. So we are left with 32 gram of oxygen against 64 gram of SO2. So the 1 mole of oxygen has been converted to 32 gram in gram. 32 gram of that oxygen, while the 1 mole of sulfur 4 oxide has been converted to 64 gram of SO2. Don't forget, we are converting the mole to mass because of the method we are using. We are using the mass to mass relationship. So it means if 32 gram, which is the 1 mole of oxygen, will react to produce 64 gram of SO2, which is also representing the 1 mole according to the balance equation, then we can now say that 91 gram of oxygen will react to produce what? Let's say X gram. So we can now find the value of that X. Find the value of the X. So by proportion, we can simply do this. By proportion, we can simply say 32 gram over 91 gram equivalent to 64 gram over S gram. If you use this method, it makes it very simple. Look at it again. If 32 gram, which is the 1 mole of oxygen from the conversion, produce 64 gram of SO2, which is also represented the 1 mole of SO2 in the equation, then 91 gram, which is the mass of oxygen put into reaction, 91 gram of oxygen will react to produce what mass of SO2? We have represented the mass of the SO2 required by the letter X. So I use this method that just put this over this, equivalent to this over this. That's like equivalent fraction. Then you can now make the X the subject of formula. So you have your X equals to 64 gram multiplied by 91 gram all over 32 gram. We are looking for the value of X. So you have 2. So our X is 182. And that's 182 gram. So it means, according to the reaction, 91.0 gram of oxygen will react to produce 182 gram of sulfur 4 oxide. Don't forget to subscribe to this YouTube channel for more videos of the chemistry calculation, and you can also share and like. Don't forget to click the subscribe button and share this video and like it. So let me try to go through it again. We are looking at stoichiometric calculation, and from this example we are calculating the mass of sulfur 4 oxide obtained when 91.0 gram of oxygen reacts completely with sulfur. Like I said, you pay attention to the 2 substances that are mentioned in the question. So we are looking at sulfur 4 oxide and oxygen. Those are the ones that you pay attention to. So from the equation, you can see that in the balanced equation we have 1 mole of oxygen reacting to produce 1 mole of sulfur oxide, SO2, which is the product. And we started from there that 1 mole of oxygen reacts to produce 1 mole of XO2. So we converted the 1 mole of oxygen to mass. How do we do that? We first of all calculated the molar mass of the oxygen gas, which is 32 grams per mole. And we also calculated the molar mass of sulfur oxide, which is 64 grams per mole. And back to the relationship, mass to mass relationship, like I said, that is what we are going to use to make it faster and easier. So the 1 mole multiplied by the molar mass, we convert it to the mass in gram. So 1 mole times 32 grams per mole of oxygen will give us 32 grams from what you can see. 1 mole of sulfur oxide multiplied by the molar mass, 64 grams per mole, will give us 64 grams. So it means the 1 mole, which is 32 grams, reacts to produce 64 grams of sulfur oxide. And therefore, from the question, we are actually looking for 91 grams of oxygen. What it's going to produce, what mass of SO4 will be, SO2 gas that will be produced from that 91 grams. So 91 grams of oxygen will produce the unknown mass which we are looking for. I represented that with X. Then using the proportion method, you put 32 over 91, put 64 over the X. And from there, we can make the X the subject of formula, and we got 182 grams. So that is the mass of sulfur